So now in section 12.3, we're going to talk about graphing logarithmic functions. And for graphing these things, we're going to be making up long tables of values by plugging numbers in. If we're going to do that effectively, we're going to have to work out logarithms pretty quickly without too many stumbles. So please remember the definition, and most important from the definition, remember that the way you work out a logarithm is by moving the base to the other side. That idea is pretty central to most of what we do in chapter 12. So you're going to find me saying that over and over and over and over again. You'll definitely get the hang of that. So let's use that to make a table of values for this function here. So to start off with, we start off with everybody's favorite number 0. And we plug that into the logarithm here. We're doing log base 2 of 0, and we're trying to figure out what that comes out to be. So we move the base to the other side, and we're trying to answer this question here. What exponent can you put on 2? 2 to the what will produce 0 as an answer. And you should realize right off the bat that that's not possible. There's no number in the world, it doesn't matter what you plug in there. And if you're thinking 0, no, 2 to the 0 is not 0. 2 to the 0 is 1. 2 to the anything will always produce a positive result. So you can't plug 0 into this. You try, you get no answer at all. In fact, the same sort of thing would happen if you tried a negative number, just the same problem. Move the base to the other side, and you're asking for the impossible. There is no exponent anywhere that would produce a negative result. So, if you can't get negative results for x, and you can't get 0 for x, that means right off the bat, before we've even got any points at all, we realize that there's a domain issue here. The domain of a logarithm, you can't plug in 0, you can't plug in negative. The only things you can plug into a logarithm are positive numbers. So that's a really essential idea for all logarithm graphs. All logarithm graphs have a domain where you cannot take a logarithm of a negative and you cannot take a logarithm of 0. So when we're making our table of values, we should only be plugging in positive numbers. Yeah, I know that's a lot, but I'll skip several of them. Okay, well, let's try these ones. Let's try log base 2 of 1. Move the base to the other side. And that, luckily, is a fairly easy point to figure out. What exponent produces an answer of 1? 0. So we've got the point 1, 0 right there. And if we plug in 2, we're doing log base, oops, wrong color. Let me get my color coding properly worked out here. That should be green. So log base 2 of 2 equals y. Move the base to the other side. And that's also pretty easy. What exponent produces an answer of 2? Well, 2 to the 1 produces 2. So that's that point there. That doesn't mean it's a straight line. Don't jump the gun. Next one. Plug in 3. Log base 2 of 3 equals y. Move the base to the other side. And that's a pretty tough one. Now, it's not tough the way these ones were tough. These ones up here were just plain impossible. There is some number that will produce an answer of 3 here. It's going to be some messy decimal. But it's so messy that I'm just going to skip it. I want nice numbers that are easy to plot, so if I come up with something like that that's a headache, I'll just skip it. Maybe 4 will be better. Let's try that. Log base 2 of 4 equals y. Move the base to the other side. We want an answer of 4. Oh yeah, that one kind of works out nice. What exponent there? Exponent of 2. So 1, 2, 3, 4, 2. And then if you try 5, you'll realize it's ugly, so we'll skip it. If you try 6, it comes out ugly, so we'll skip it. You try 7, it comes out ugly, we skip it. The next one that comes out nice is 8. Log base 2 of 8 equals y. Move the base to the other side. dang it, oops, sorry about that. Hit the wrong key. There we go. And that one comes up pretty nice. What exponent on 2 produces 8 for an answer? 3 does. 5, 6, 7, 8, 1, 2, 3. And if you look at these points that we came out with that were nice ones, this one here, and this one here, and this one here, and this one here, you'll recognize that those look kind of familiar a little bit. When we were back in section 12.1 and we were graphing exponential functions, we saw those numbers, but on a different table of values. We saw those numbers on a table of values where they went like this, where the x was 0 and the y was 1. The x was 1, the y was 2. 2, 4, 3, 8, and so on. And if you remember, that was from the equation y equals 2 to the x. So the logarithm that we're graphing right now and the equation y equals 2 to the x, they have kind of the same table of values, except the x's and y's have been swapped. Wait, that's some really loaded vocabulary. We've heard that vocabulary before. The x's and y's have been swapped. That means they're inverse functions. That means that the exponential graphs that we did in 12.1 and the idea of inverse functions that we did in 12.2 combine together to give us graphs of logarithmic functions. So since this has the reverse table of values to that, that means that this graph is inverse to the logarithm graph. So let's draw that exponential graph. 3, 8, 1, 2, 3, 4, 5, 6, 7, 8 up there. And think back, was that the entire exponential graph? No, there was more to the exponential graph, wasn't there? The exponential graph had this asymptote thing going off to the left, like so, where it leveled off along 0. What about the green graph? Does the green graph have the mirror image that we would expect it to be? Remember, when we were learning about inverse functions, the graph of a function and its inverse are supposed to be mirror images. So, if this blue part goes off along the x-axis like this, the mirror image, the green graph should go down here like this. And think about what those points would be. That would be like a fraction for x and -1 for y, and a smaller fraction for x and -2 for y, and an even smaller fraction for x and -3 for y. So let's just do one of those. If you plug in 1/2 for x, you do get an answer. Think about what would happen if you change this around. You're going to be getting 1/2 is the answer. What exponent does it take to get that answer? Yep, sure enough, -1. That point is right there. So the graphs actually are mirror images. What that really kind of boils down to is there's a huge shortcut you can use for graphing these things. When we did this problem now, we're looking back at what we did and we realized we did way more work than we really needed to do. But we kind of needed to do it because we needed to understand what's going on and learn that there is a relationship, and the relationship exists for good reasons. But once you learn that these things are mirror images, that's going to make your life a lot simpler when you try to graph another problem. So let's do one more problem and see how it works when we do things the quick way. So we're going to do log base 6 of x. Step 1 is to figure out what is its inverse graph. Well, base is 6, so the inverse graph would be 6 to the x. Graph 6 to the x. And You can still use a table of values if you like. It's pretty easy. It goes up really quickly. By the time you plug in 2, it's going to be off the top of any reasonable sized graph paper. And if you plug in negatives, of course you get fractions. 1, 2, 3, 4, 5, 6. So y equals 6 to the x looks like this. And then draw the inverse. And remember, the inverse of a graph is a reflection, a mirror image, across this diagonal line here. So the inverse graph, that point will be here. This one at 1, 6 will be over here at 6, 1. 1, 2, 3, 4, 5, 6, 1. And yeah, there was going to be a 36, 2, but that's way off to the side. And there's going to be a vertical asymptote here. So make sure when you graph these things that you've got that vertical asymptote thing going on. Just like when we did exponentials, we had to have a horizontal asymptote. So our graph here looks like that. That was a lot quicker than the one we did a second ago. I mean, there's sort of a little table of values happening over there. And by reflecting those back and forth, we're kind of getting a table of values for this one. But really, these logarithm graphs don't have to be super tedious and time-consuming. You can go ahead and do the reflection, get the inverse graph, and then reflect to get yours. And notice, like I mentioned earlier, the domain for this thing, or all these points, happen only for x bigger than 0. All logarithms have that limitation. You can only plug positive numbers into logarithms. Keep that in mind. That's going to come back again.